Hello everyone, I am Anjali Deshpande, working as Assistant Professor at Walchand Institute of Technology, Solapur. Welcome to the tutorial on Secret Key Cryptography. Here the learning outcome is student will be able to encrypt and decrypt the message using Caesar cipher technique. Let's start with the current scenario. How secure is your network and your data? Today's biggest problem is cyber threats. Challenges in cybersecurity are evolving on a daily basis. Network security is a vital organ of the IT infrastructure system. With the changing face of the internet, from desktops to handheld devices and from data centers to cloud computing, network security too has changed colors. More and more devices, networks, and people are vulnerable to cyber threats like phishing, attacks, malwares, etc. Cryptography is the practice and study of techniques for secure communication. It is the science of secret writing. If you need to send a secret message to a friend, how could you prevent other people from reading it? One way is to encrypt the message, that is, use a secret code that only you and your friend knows. In this video, we are going to try this activity to learn how to create secret code using Caesar cipher technique. Symmetric encryption transforms plain text into ciphertext using a secret key and an encryption algorithm. Using the same key and a decryption algorithm, the plain text is recovered from the ciphertext. Symmetric encryption was the only type of encryption in use prior to the development of public key encryption in the 1970s. In this video, we begin with a look at general model for symmetric encryption process. This will enable us to understand the context in which the algorithms are used. Then we examine a simple algorithm, that is Caesar cipher, in use before the computer era. A symmetric encryption scheme has 5 main ingredients: plaintext P, ciphertext C, secret key K, encryption algorithm E, and the decryption algorithm D. Plaintext is the original intelligible message or data that is fed into the algorithm as input. Encryption algorithm performs various substitutions and transformations on the plaintext. Secret key is also input to the encryption algorithm. The key is a value independent of the plaintext and of the algorithm. The algorithm will produce a different output depending on the specific key being used at the time. Ciphertext is the scrambled message produced as output. It depends on the plaintext and the secret key. For a given message, 2 different keys will produce 2 different ciphertexts. Decryption algorithm is essentially the encryption algorithm run in reverse. It takes the ciphertext and the secret key and produces the original plaintext. Sender and receiver must have obtained copies of the secret key in a secure fashion and must keep the key secure. If someone else can discover the key and knows the algorithm, the communication using this key is readable. Now pause this video for a minute and write down your answer. The question is, how many keys are required for 2 people to communicate by the use of secret key cryptography? The answer is single key. Symmetric encryption is a form of crypto system in which encryption and decryption is performed using the same key. Cryptographic systems are characterized along three independent dimensions. The first dimension is the type of operations for transforming plain text to ciphertext. All encryption algorithms are based on two general principles. Substitution. Here each element in the plain text is mapped into another element. Transposition. Elements in the plain text are rearranged. The fundamental requirement is that no information be lost. The other dimension is the number of keys used. If both sender and receiver use the same key, the system is referred to as symmetric, single key, secret key, or conventional encryption. Whereas, if the sender and receiver use different keys, the system is referred to as asymmetric, two-key, or public key encryption. The third dimension is the way in which the plain text is processed. A block cipher processes the input one block of elements at a time, producing an output block for each input block. And a stream cipher processes the input elements continuously, producing output one element at a time as it goes along. Here we examine classical encryption technique, that is Caesar cipher. The earliest known and the simplest use of a substitution cipher was by Julius Caesar. The Caesar cipher involves replacing each letter of the alphabet with a letter standing k places further down the alphabet. Let's consider an example. The plain text to be encrypted is hello and the key is 3. Let us assign a numerical equivalent to each letter. So a numerical equivalent for A is 0, for B it is 1, and so on. For each plaintext letter P, substitute the ciphertext letter C. A shift may be of any amount so that the general Caesar algorithm is C is equal to P plus K mod 26, where K takes on a value in the range 1 to 25. In our example, the first value of P is H, whose numerical equivalent is 7. 7 plus 3 is 10. 10 mod 26 is 10. And 10th letter is K. So, H is replaced by K. By shifting each letter by 3 to the right, the resulting ciphertext would be KHOOR. The decryption algorithm is simply P is equal to C minus K mod 26. Caesar cipher is considerably easy to break. If it is known that a given ciphertext is encrypted using a Caesar cipher, then a brute force attack can be easily performed simply by trying all the 25 possible keys. Now try the following example as an assignment. For a given plain text, encrypt and decrypt the message using Caesar cipher technique. Plain text is cryptography and network security and key is 4. In this tutorial, we have covered the basics of secret key cryptography. Thank you.